All right, so this is our first video for the test 3 review. We're just going to jump right in. On number 1, part A, it says find the inverse of this function f of x equals negative 2x minus 4 over x minus 3. So we could rewrite this first off as y is equal to negative 2x minus 4 over x minus 3. And then with the inverse, or the opposite of this, we want to switch the x's and the y's and solve for y in that case. So we could rewrite it in the inverse as x is equal to negative 2y minus 4 all over y minus 3. Again, wherever there was an x over here, I put a y in its spot. Wherever there was a y, I put an x. And now I'll solve for y in this new equation. So I'll put the x over 1. That way I have a fraction on the left and a fraction on the right, and I can just cross multiply. So I'll say x times y minus 3. That will give me xy minus 3x equals 2. When I cross multiply the 1 times the negative 2y minus 4, I get, once again, negative 2y minus 4. Now, I have two y's in this equation, and I want to get it down to 1. So I'm going to do some movement. I'm going to switch sides and switch signs. So I'm going to move this 2y over here to the left, and I'll simultaneously move this 3x over here to the right. So I get xy plus 2y equals to 3x minus 4. Again, you switch sides, you switch signs, so those negatives turn to positives. And now what I can do to go from 2 y's in the equation down to 1 is factor a y out. So I get x plus 2, taking the y to both of those terms, still equal to 3x minus 4 over here. And now I can isolate the y and get the actual inverse of this. I can divide both sides by x plus 2. And so that's my inverse. The inverse function would be 3x minus 4 all over x plus 2. And now for part B here, the graphs of f and the inverse of f are symmetric with respect to the line defined by y equals to x. We talked about this in class when we talked about inverses, but essentially if you have your coordinate plane, you can draw this line from diagonal to diagonal, and whatever's happening in the upper quadrants is also happening in the lower quadrants. So, if you have a piece like, say, this, you would have a similar piece down here for its inverse. Something to that effect. Moving on to number 2, complete the table, just converting from exponential form to logarithmic form and vice versa. So with this 4 to the x equals 16, I could rewrite this as a log with base 4. 16 here is equal to x. Just 4 to the x equal to 16. We don't have to solve this. With the next one, I could say it's a log with a base of 25. 5 is equal to a half. Just using that log loop, 25 to the 1/2 is equal to 5. And then this would be a log base 4 once again. 1/16 is equal to negative 2, because 4 to the negative 2 is equal to 1/16. And now on these, I'll just go the opposite direction. So this is the same thing as 9 squared is equal to 81. Over here, we would write this as 9 to the 2, or 9 squared equals 2. That's 243x. And again, you don't have to solve that. Just leave it in that form. And this would be 5 to the 4x is equal to 1080. Just bouncing back and forth from exponential form to log form. On to number 3 here. We want to draw the graph of 2 to the x minus 5. Be sure to label the intercept, the asymptote, and 2 additional points. So to start with, for the intercept, you just plug 0 into your function. So if you plug 0 in for this x right here, you're looking at 2 to the 0. Sorry, 2 to the 0 minus 5, which is the same thing as 2 to the negative 5. And so that's essentially 1 over 2 to the 5th which is 1 over 32. So your intercept is right here, over 0, just up a very small bit, 1 over 32. And then for my 2 additional points, I could plug in numbers to see what I could get. You could always go with 1, 2, and 3, but I'm going to plug in 5. That's a good one to plug in because when you plug in 5 for that x, 2 to the 5 minus 5 is 2 to the 0, and anything to the 0 power is 1. So I plugged in 5, and it gave me out the number 1. So over 5 up 1. And then I could plug in the number 6, another good one to plug in because when you say 2 to the 6 minus 5, gives us 2 to the 1, which is just 2. So I could go over 6 up 2, and then this would be my exponential function. And I would have this asymptote here on the x-axis, this line that it gets closer and closer to but never quite touches. The domain of my graph from left to right is from negative infinity to positive infinity. My range, the lowest this graph gets to is that 0, and the asymptote gets closer and closer but never quite gets to 0, hence the parenthesis. And then the top, it goes all the way up to positive infinity. The graph is either increasing or decreasing, circle 1. Well, I can see that this graph is headed up, so it's increasing. On the interval, well, it's increasing the entire time from negative infinity to positive infinity. It has a horizontal asymptote, this line going straight across at y equals to 0. And it has a y-intercept of 0, 1 over 32. So you could use your calculator on this. You could go to the y equals function and say y is equal to 2 to the x minus 5 and get the same graph. I would do that here, but I'm having some calculator issues. So we'll stop the video here, and we'll go to the next problems in the next video.